So in 4.1c of college algebra, page 353, top of the page, what we're trying to do here is we're trying to find out what the formula for the inverse of a function looks like. Okay? So given an f of x, we're trying to find out what the inverse is going to look like. And there are certain rules here. And at the top of 353, obtaining a formula for an inverse, they give them to you. So let's go ahead and take a function. F of x equals 2x minus 3. Okay, so we're going to follow the rules, and what we end up with is the formula for that inverse. So for example, if I were to get a graph like this, and let's say that that's this function, and I wanted the inverse would look like this, and that's what we're going to find, is the equation for this graph right here, its inverse. So bear with me as we go through the steps. Step 1 says we're going to replace f of x with y. So we're going to say y equals 2x minus 3. That's all we did. We just put a y there instead. Next thing it says interchange x and y. So we're going to put an x there and a y there. Next thing that we're going to do is we're going to solve for y. So we're going to move everything around so that y equals something instead of x equals. So we're going to add 3 to both sides. Then we'll divide by 2. Those cancel, and we end up with y equals x plus 3 over 2. Okay? And the last step is we're going to replace y with f inverse. And we're done. That right there is the inverse of that. So if you reflected it across the x equals y axis, that's what you would get. You would get this equation that we ended up with right here. Okay, so I erased everything. Here's my original. Here's the inverse. Now, let's see what happens here if I were to put 5 in for my x. It gives me 2 times 5 minus 3, which equals 7. Okay? Now let's go to the inverse, and I'm going to put 7 in here. Seven plus 3 is 10 over 2, which equals 5. Okay, now look and see what happened here. When I put 7 in, I got 5. When I put 5 in, I got 7. So I put 7 in, I got 5. I put 5 in, I got 7. Okay? So the function f took the number 5 to give me 7, and the inverse here of 7 took me back to 5. Okay? So it took me back to what I started with. Okay? So good to remember. So if we were to graph these two, we'd end up with a line because it's a linear equation here. And one of the lines, our 2x minus 3, is going to look kind of like this. And our x plus 3 divided by 2 is going to look something like this. And it's going to be reflected across the y equals x, which is what we have at the top of page 354. And in the middle there it says, when we interchange x and y in finding a formula for the inverse of f of x equals 2x minus 3, we are in effect reflecting the graph of that function across the line y equals x. Okay? Middle of page 354 in blue, the graph of the inverse of the function is a reflection of the graph of f across the line y equals x. Okay, let's look at example 8. Okay, so this picture that I have right here is the graph of that. And notice, vertical line test, horizontal line test. It's a function and the inverse is function, so it is 1-to-1. All right, so the first thing it asks us to do is determine whether the function is one-to-one. Well, we did the vertical or the horizontal line test and found that it is. And later on, we'll work on finding out if it is without graphing it. But so we're in the second one. B says if it is one-to-one, find a formula for its inverse. So we're going to follow our steps. We're going to replace g of x with y. And then we're going to switch. And now we're going to solve for y. Now we're going to take the cubed root. Okay? So that ends up being my inverse. Now I have to replace y with g inverse of x. So that's the cubed root of x minus 2. So this is the inverse of that. Okay. And the next thing they want you to do is to graph the function and its inverse. And one of the ways you can check to see if we have the right equation, and this isn't necessarily always a guarantee, but all we have to do is plug in a number here. And so let's plug in 3 for x. So that gives me 27 plus 2 is 29. And then I look down here, and I put a 29 in there, and I get the cubed root of 27, which is 3. So I put a 3 in here and got a 29, put a 29 in here and got a 3. Okay, so that gives me a pretty reasonable idea that my answer is, or my formula that I have for my inverse is the correct one. All right, so to do the graph, you end up just plugging numbers in until you get the graph. You do know, though, that it's reflected across x equals y, or y equals x. And if you can kind of guess, you can kind of look here and see, okay, this point here looks like it's about 1 3/4. So that means the reflection is going to be about here. And this here, it's going to my other one is going to cross there as well. This point here is going to be about here. You know, so you're just kind of guessing what it's going to look like. So something along that line going to be reflected across that x equals y. Okay? So another idea, bottom of page 355, is to show that one function is the inverse of another. And what it's saying is that suppose we are to use some input a. So we have a, and we put it in, and we got an output of f of a. Or, you know, a y value. We put in an x, we get a y. We put in a, we get an f of a. Okay? So suppose that we are to use some input a for a one-to-one function f and found its output f of a. The function f inverse would then take that output back to a, which means if we were to put it back in the function machine and go the other way, it would give us our a. The same would happen if we had a b. If we had a b, we put it through the function machine, and it gave me an f of b. When I put the f of b back in and did the inverse, went the opposite direction, it would give me my b back. And in that table, in the bottom of page 355 in blue, it gives you a summary of what I just said there. If a function f is one-to-one, then the inverse of that function is the unique function such that each of the following holds true. So what they're saying is that if we took the inverse of f of x, that would give me my x. Okay? Or if we went the other way and put f of the inverse here. So this is just a composition of functions here. This would be written basically f negative 1 composite f of x. But you know, I don't like writing it that way, so that's why I like to write it this way. It's easier for me to do, especially when they give me a problem to do. So for example, the one they give us for example 9, they give us f of x, and they say that that equals 5x plus 8. Okay? And they want us to use the compositions of functions to show that f of negative 1 of x equals x minus 8 over 5. So what they're asking us to do is prove that this is the inverse of this. Okay? So this and this are inverses of each other is what they're asking us to do. And the way we find out is that if we take the composite, we will get as an answer x. So after everything is said and done, if we get x, then it is the inverse. It's the proper formula for the inverse. Okay, so let's go ahead and do that. So what we're going to find is f negative 1 composite f of x, and then we're going to find f composite f inverse of x and see what we get to see that each is x. So let's do the first one here. So let me erase this one, and we'll do that. We'll come back to that in a minute, but we'll just do this first one right now. So what we've got actually is the inverse f of x. Okay? It makes it easier for me anyway when I look at it that way. So f of negative 1, f of x is 5x plus 8. Okay, and I got that from right here. I just replaced my f of x with 5x plus 8. Okay? Now, what I'm going to do is I'm going to put this whenever I see an x up here for my inverse. So, f of negative 1 of 5x plus 8 equals, I'm going to put a 5x plus 8 in for my x. I'll put it in parentheses so I remember, and then minus 8 over 5. So that's taken from right here. Okay? Then I go. This disappears, and I get 5x over 5. My 5's cancel, and what am I left with? X. Okay, which is what I want. Now let's go the other way. Let's look at it as f of x composite and see what we get. Alright, so this time I'm going to do f of f inverse x. So that's going to be f of, this time it's going to be that, x minus 8 over 5. So now I'm going to take that and put it in here. So 5 times x minus 8 over 5. And I've got a plus 8. And that plus 8 is this 8 right there. And let's see here. When I do the math, I get 5x minus 40, This cancels with this. This turns into 0, and I'm left with x. So that turns into x too. So I just proved that this equation here, this function here, is an inverse of this function, and that this one is an inverse of that one. Okay? So, has to be true for both of them. You can't just get by with just doing it one time. You've got to do both this one, f inverse f of x, and then f of f of inverse of x. So you got to do this one and get x for both of them to show that the equations are both inverses of each other. Okay, top of page 356. I'm just going to kind of talk through this real quick. It's a very small section, but it's important for you to at least listen to me talk for a minute. There are going to be some times where the inverse of a function is not a function. It doesn't pass the horizontal line test. So therefore the inverse is not a function, but it could be that if I get a graph like this and I get a graph like this, it could be that I can restrict the domain, the values that this graph can be, so that the inverse of that graph is a function. So it could be that I look at this and I'm like, you know what? I'm only going to look at the point between here and here, so that when I do the vertical line test, it only crosses at one point, so I can say that it's inverse. Within this boundary here and here is a function. Because now when I whip it across the y equals x, maybe it gives me this. And that is a function. So even though the whole thing isn't one-to-one and the inverse is not a function, if I just take a little piece of this graph, then its inverse could be a function. So I don't think there's any of those in the homework, but it is good to at least be aware of that. They don't spend much time. In fact, they don't even give an example, but I thought I'd at least show that to you. So that is the end of 4.1.